I have talked about the inventory simulation models. So in the lecture slide, we mentioned the exercise 10 in the chapter 10 exercise 10.24. So here I give a brief explanation about how should we build and run the simulation in Excel. So this is the exercise. So if you have the textbook, you can open your book on the page 326, and you find the information about the exercise. So this is about appliances company, and they are interested to investigate their inventory policies in order to reduce the total cost and stock out. So this is some brief information about this exercise. So they know the weekly demand, so which is normal distributed with a mean of 25 units and a standard deviation of 7 units. And make it bigger. And they also know the current inventory policies. The reorder point is 70 units, and the order quantity is 300 times each time when they places an order. The lead time in the weeks to receive an order from the distributor follows a discrete distribution. So this is also a combined stochastic inventory problem. Both demand and the lead time are stochastic factors. About the distribution, discrete distribution about the lead time can be found in the textbook. And then we have the cost information. We have the cost for 1 week, 1 unit product, $20. We have the fixed ordering cost, $300 per order. And then we have the stock out cost is $100 per unit. So the initial inventory level is 140. So the exercise includes 3 questions or 3 steps. First step asks you to simulate 52 weeks of the operation to calculate the total semi-annual costs and the percentage of stock outs for the period. So this is about the exercise. Now let's see the Excel model or template for the exercise. You should have actually downloaded the template for this exercise. So in my templates, including a bit more calculations or formulas already, so that I can save some time to type the formulas. Here I mainly explain how the inventory control logic is simulated in Excel. So let's see this exercise layout. If I could make it bigger. So first we have the column A. So you decided to simulate 52 weeks. So we should have 52 entries. Then in order to simulate an inventory model, so we need to actually find the key relationships about the inventory and the demand and the lead time. So here we actually use this workbook to calculate the beginning inventory in each week and the units received at each week, available inventory at each week, beginning of each week, and the demand and how many units are satisfied or demand fulfilled in each week. And then you have ending inventory after each week or at the end of each week. Then we have the stock odds each week. So here the stock odd is the units are not satisfied. And then we calculate the ending inventory plus order. So this is a little bit more tricky. So when you place this order, when the lead time is longer than your review period. So in this example, you should know we review the inventory each week. So you can see, and then we decide if you place the order or not. So the lead time is a stochastic distribution. So the range is from 1 week to 6 weeks. So when the lead time is longer than the review period, so quite likely you make repeated order if you did not check the outstanding orders or the orders on the shipping on the way. So here, that's why we have to calculate ending inventory plus the outstanding orders. And then here we calculate or determine if an order should be placed or not. Then this is the random factor for lead time. We generate a random value for lead time each time you places the order. And then we have arrive on the day. So here shows how many days when will the order arrive at the warehouse or your shop. And then in the last 4 columns, you can see we calculate holding cost, stock order cost, and total cost. So this is an inventory or demand, inventory control and demand satisfaction logic or demand fulfillment logic. And then on the middle, we have a section from column R to column U. So these 4 columns, you can see we have some parameter typed in. So we have a lead time distribution here, discrete lead time distribution. We have used that many times. So given this information, you should think about to use a lookup function. And then we have a parameter for order quantity, holding cost, stock order cost, or ordering cost. And then here on the bottom, in the middle section, we have a average holding costs, stock cost or performance measures from your simulation, 200 times simulation. In this case, we reuse a table, data table, to run multiple replications. So we'll come to that point and see how to do that again. So in this example or exercise, the most important part is how you actually figure out how the inventory is handled and the demands are satisfied or fulfilled. So in the current 2 rows I entered, you can see how this actually realized in the Excel calculation. So first, we know the initial inventory in this store is 140 units. And in week 1, we're interested in calculate how the demand is generated. So here first, let's see. We know initially we have 140 units. And in this week, there's nothing actually ordered because it's the beginning of your simulation. So we'll assume there will be none orders. So the units received is 0 in the first week. And then we know the available inventory is the current inventory on hand. So here the demand is a stochastic factor. So remember the demand is a normal distributed with a mean of 25 and a standard deviation of 7. So we use a normal inverse function to generate a random demand in this example. However, have to be careful to use a normal distribution in the simulation because the normal normal distribution cannot avoid a negative value. So when you run many replications, it quite likely will generate negative values, even though the probability is low. So in this case, we requires only consider the positive random values you generated. So we use a max function to only keep the positive or non-negative values. Apart from this, in the exercise, I also mentioned you should only consider the integer demand. So we also use a round function here, the round function, to make sure you will get integer demand values. So just double check this function, make sure you understand everything. And the next column, we generate demand. We consider the demand satisfaction situation. So the demand fulfilled. If you double click this cell, you can see you just compare the current available inventory and the demand. And then only the minimum value among these two values can be satisfied. So in other words, if your available inventory is greater than your demand, of course, all demands are satisfied. If your available inventory is less than demand, then there will not be any inventory satisfied. Oh no, there will only be the available inventory satisfied. So that's why here we use a minimum value between available inventory and the demand to be the demand fulfilled. Ending inventory. So this is actually the inventory at the end of each week. So after you satisfy your demand, the rest of the inventory will be the ending inventory. So we use available inventory minus the demand fulfilled. So that's pretty straightforward. Then we consider the stock out. So the stock out values is when your demand is higher than your available inventory. Actually, some of the demand will be lost. So here we use demand minus available inventory. If the value is positive, then there will be some stock out. So we use a max function to calculate the stock out. And then here, the ending inventory plus order. So this actually is in week 1. So there is no previous orders. So we just take the ending inventory at the week 1 as the value. So we just use G2 because there's no orders on the way. And then there is a decision to make. So if you should place the order or not. So the decision is made based on the reorder point in your ordering policy. So our reorder point is given in the cell T12. Value is 70 in the current situation. So you just compare the ending inventory plus order. So be careful here. You have to use the inventory on hand and on the way. So it's two parts. That's why we have to calculate ending inventory and plus the outstanding orders. So here we use I2 to compare with reorder point. And then the lead time. So here is not very important to use a zero or a real lead time. So here you could just generate a lot of lead times, even if you did not place order. But here I just make it more strict. So if you place an order, then we use a distribution on the right-hand side to look up the distribution and find a simulated random value for lead time. So sometimes it's 0 if you do not place an order. So this is a random value. and then we calculate if you place an order, arrive on the day. So of course, if you place an order, then we calculate the current time plus lead time plus 1 week. This is the time the order quantity will arrive. So that's how we do the calculation. So after we did the first week calculation, we cannot just drag everything down to finish the 52 weeks. So it's important you should actually also set up the week 2, because you can see in the week 2, beginning inventory actually is the ending inventory in the first week. So the second week's inventory at the beginning is equals to the inventory at the first week's, at the end of the first week. So here we have to make this logic calculated. And then units received. So in this case, we have to consider all the previous weeks order situations and counts. So here we do counts for all the previous weeks. For example, here you can see I check all the week before week 2, and if there is an order and the arrival on day will be the same with the current week, then that means one order will arrive at this day. And then the order quantity is given in a cell T11, so I times T11. If you have multiple orders will arrive at this day, this also use the same formula. And then available inventory in this week will be the inventory at the beginning of the week plus the units are received. And the demand again is a random value, so we just drag down the formula from the week 1, and the date demand fulfilled. So the demand fulfilled from week 2 is actually also the minimum value between your demand and available inventory. So it's no trick. And any inventory is a rest of the inventory between the available inventory and the demand. And the stock odds is the maximum value you calculated. So if your demand is more than the available inventory, there may be a stock odds. So then we calculate the ending inventory and orders. So in this second week, then we have to check if there is a order on the way. So you have to plus this order. So that's why we check the previous week's order status and see if there is order placed in the week before, and then you count the order quantity by the if times order quantity. So here the I2 minus F3, make sure you actually counted the previous outstanding orders. So this formula is actually a clever way to accumulate the outstanding orders over multiple weeks or maybe multiple orders. If you place the order, again, it's repeated, and the lead time is given. So now you can see, so the lead time again is a random value, and the arrive time is the same. So just drag down from the previous week. So here the ending inventory, you can also consider, it's actually maybe, So after we finish this 2 weeks calculations or logic, basically we can repeat the calculations for the following weeks. In this case, you could just select the cells in the week 2 and then copy or drag down this 42 weeks. So that's how we actually did the calculation here. Now you can see you got the 52 weeks simulation, and then the costs can easily be calculated because we know the cost parameters in this exercise. So basically, it's a holding cost calculated by the unit holding cost times the ending inventory. The ending inventory also means the inventory hold or carry over 1 week. So it's just a repeat for 52 weeks, and stock out cost is a stock out quantity times a unit stock out cost. So order cost related to your order status. So if you place an order, then that's order cost. And the total cost is a sum up of the holding cost, stock out cost, and order cost. So repeat for 52 weeks, and we calculate our total cost for 52 weeks for the different categories. So now we continue. Sorry, I just probably went out a bit. So after we calculate all these costs, then we can do multiple replications. So for one replication, we mentioned before, it means nothing. It's just a random result. So if we run multiple replications, the average value may be more representative. So now we just recall the data table in Excel that then help us to do multiple replications. So the exercise asks us to do 200 replications. So first we set up a data table in Excel. So now you can see this is in the column W to column W, AB. So that's the data table we set up. And in the first row, you just choose the value you would like to calculate for each replication. So double click, you can see. So this is the value, the average cost from the total cost over 52 weeks for 1 year, or another way. And then the others also same. And then we do data table. So it's not new for us, so I do a little bit fast. So we first select all the contents in your data table, so 200 replications. Select all these cells and click data table. And then we do column-wise calculations. So we choose a column input cell. Again, we need a dummy cell, and then you just click. So that's how we do the 200 replications. So based on these 200 replications, in the middle of the Excel workbook, you can see we calculate the average holding cost, stock out cost, and average ordering cost, and so on. I just realized the exercise asked for a semi-annual cost. do the operation to calculate the total semi-annual cost and the percentage of stock odds for the period. So here we actually do our annual cost. So semi-annual cost probably we divided by 2. So for the time being, we stick with the annual cost in the video. So that's actually, we finished the simulation with 200 replications, and this are the output. You can see the total cost is about $148,110. So the average number of stock odds is 5.92 weeks. So over the 52 weeks. This is actually already pretty good. However, now we only looked into one situation for one specific order policy, which is 370. So in this case, we finish the question A. And now if we continue with question B, the manager actually would like to evaluate the economics of ordering different order quantities each time. So in this case, we can use the scenario analysis to look into the different situations. So here I already set up the different scenarios. So we have also used scenario analysis previously. So I just quickly take one example. For example, we consider the order quantity 250 as an alternative. Then the value will replace the value in the cell T11 in our Excel workbook. And then now if we edit this scenario, now we can see the scenario name is Q250, changing the cell replace the cell of T11, and then click OK. Then we put the value, a new value, 250. Okay, and then you will add more or extra scenarios. So then in the summary, you click the button summary, then you can decide what values you want to take as output. So in this case, I take the cell S25 to S29, which are the costs and stock output. Okay. And then it will take some time to get output, which is not too clever to do a very long scenarios. So here you can see this is the output we got from the simulation. There may be a mistake. So here I have a current value 250. Actually, our current value is 300. Then we have 250, 270, 300, 325, 350. Then compare the total cost in the last in this row. You can see actually the order lies is better. So the order quantity maybe should be reduced to 250. However, we'll risk the stock order rate to the over 6 weeks. The current situation is 5.77 weeks. So that's one result. So if you want to rename this summary report, then we name it as a question B, and then we're done. So now we completed the question B. So then we try the question C. The manager would like to evaluate the options to change the reorder point. The current reorder point actually is 70. So the manager is interested in changing them to 60, 80, 90, or 100 units. So we just redo the scenario analysis by adding different values. So for example, I can edit the original one. So I do a reorder point 60, and I change the cell of T12, and OK. I change it into 60, OK, and then repeat this into R70, T12, OK, R80, better take this one. Can do R90. Okay. Then the same, I would like to have the same output, so nothing should be changed. And then it will get a new worksheet as a scenario summary. So now got to see the output for the different alternatives from 60 to 100. And again, the total cost, you can see the current order quantity equals to 300. Now you can see we have the total cost from 144,000 to 164,000. So we're pretty sure we should also reduce the reorder point in this scenario. So we can rename the value as a C. So in the B, I can put here the reorder point equals to 70. So situation. So let's just repeat what we have done previously in the simulation. So in this exercise, actually, we could also do something extra, especially in the scenario analysis. So far, we only consider to change the one decision variable in your order policy. You could also think about to change them both. So that's also possible. For example, I can edit several new scenarios. For example, I do a Q250 R60. I change the cell of both, and then I set up the value for 250, 60, and then I change this one into probably Q300 original scenario, and the parameter cell, and then I do 370. Okay, and I added more scenarios. Of course, you can exhaust all the combinations of Q values and R values. Here, for the time reason, so I just take some examples which I think may be good. Which is 275 to 60. So I can continue. So I could also delete some. So you could continue with these scenarios. So here for this time-wise, so I just give several examples. Now you can see if we have multiple different variables, actually the calculations also take a longer time. So now you can say I got the result in the row here and row 12. So of course, obviously the other policy 250 and 60 gives lowest expected total cost. However, also create the highest stock odds rate. So stock odds definitely is not a good thing for the shop's reputation. So it would be nice you can consider both the objectives and make a more reasonable suggestion about the inventory policy. So that's what I would like to talk about for this exercise. I suggest you first try the exercise yourself. If you have difficulties, then you can come to this video. However, the video is a bit too long. It takes really some time to go through that. So you can also directly look into the solution file and make sure you can do this exercise. Thank you for now.